Sí, eso. Bueno, excelente, comencemos. Antes de cualquier cosa, quiero saber quiénes que estén conectados o acá no están haciendo un doctorado, sino una maestría. 4. ¿Sí? Y entre, bueno, a hacer yo también. Ok. Bueno, ahora lo que pasa es que este es un curso principalmente de doctorado, ¿no? Entonces el curso realmente, yo pregunté a él, a Miguel, bien, entonces lo vamos a inglés, sí, doctorado tiene que ser en inglés. Me decía, uy, no, en español, porque me van a asustar. Pero eso lo digo a Miguel, lo siento, o sea, en el programa es inglés, punto. Sí, no voy a discutir eso, pero podemos negociar un poquito, ¿sí? Ahora, o sea, para mí la idea es que se haga en inglés, en realidad. Y para los que están de doctorado, igual no hay excusa. Para los de posgrado, pues, es tal vez otra cosa, pero podríamos, o sea, intentémoslo, pero si sienten que no funciona, podríamos hacer al menos miti-miti. Sí. Eh, ¿sí? Que empecemos con una clase, o sea, hacemos mitad inglés, mitad español o algo por el estilo. Yo creo que yo tengo un buen inglés, no es impecable, pero debería ser bien comprensible y, y bueno, es una buena práctica. O sea, yo siempre me asombro, o sea, cuando vine, yo les pregunté, ¿y las clases en pregrado vamos a hacerlos en español o inglés? Y me decían, no, en inglés, dentro de lo posible. Lo hice un semestre, después ya no, porque se quejan. Pero en la maestría. Sí, sí, sí. No, pero tampoco. Ahora ni siquiera en el doctorado, donde tenemos que publicar en inglés inclusive. Entonces, no, ya hay como bordes. Aunque esto siempre, como yo entiendo que hay poblaciones y poblaciones, ¿no? O sea, algunos si quieren, inclusive en pregrado. Ahora, esta semana me pidieron que cambiáramos la clase de inglés, pero es como la mitad que lo quiere, la otra que no quiere. Entonces eso siempre es como un poco difícil. Pero bueno, entonces ya estamos hablando de cómo el curso, pero no me he presentado, pues la mayoría me conoce, pero no todos. Entonces yo soy el profesor Félix Mo, mucho gusto a todos los que todavía no me conocen. Soy profesor asociado en la facultad ya desde hace, no sé, 3 años, pero llevo 6 años ya acá. Antes fue profesor invitado, pero decían después de un tiempo ya más que 3 años invitado tampoco se puede, o sea, o visitante, fue visitante, pero ya fue visitante como muy permanente, entonces ya lo cambiamos de modalidad. Tengo un doctorado en inteligencia artificial en Alemania, sí, lo hice en el 2016, ya casi cumplo 10 años con mi doctorado. Vine a Colombia de mochilero, conocí a una señora, eh, y así en un momento también terminé aquí como de manera más permanente. Em, sí, y bueno, yo dicto todas esas materias que tienen que ver con analítica de datos, ciencia de datos y inteligencia artificial. Y bueno, ahora la de Deep Learning Avanzado. Mm, entonces ya, bueno, esto es sobre mi persona. Hablemos un poco del curso, entonces. Entonces ya les mandé ayer ok. Entonces ya ayer les mandé un poco la agenda. ¿Fue grabando? Sí, sí. Ya está grabando. Ok. Entonces, un prerequisito del curso es que uno ya sabe de Deep Learning, en realidad. ¿sí? Ya uno sabe cómo funcionan los optimizadores en PyTorch, qué es la diferencia entre un Adam y un Stochastic Gradient Descent. Todo lo que vimos nosotros ya en el curso de Deep Learning en la maestría. Se supone que se sabe cómo funciona el train loop en PyTorch para entrenar una red básica. Y cómo funcionan los temas de inicialización de pesos en la red, que es batch normalization, que es dropout, todos esos temas básicos que vimos ya en... Si algunos no los ha visto, no necesariamente quiere decir que aquí no lo va a entender, pero pues realmente es una base importante. Lo que voy a hacer es que voy a compartir los vídeos, las grabaciones de Deep Learning, aquí también para los que no lo han visto, pueden recuperar un poco ese contenido, ¿sí? Pero hay una razón porque esos son dos módulos, ¿sí? O sea, y lo otro no es un preámbulo rápido, sino también tiene su complejidad. Entonces, esa es la primera vez que se dicta ese curso, entonces no tengo todavía como mucha experiencia en la docencia de estos temas, pero yo creo que por el momento que vamos a poder lograr todo este programa y va a ser bien increíble, ¿no? O sea, al final aquí realmente van a ser como muy expertos en el tema de Deep Learning, pero también va a ser como no para rascarse el ombligo, para decir algo. Entonces, aquí tenemos como tres áreas grandes, que son, el primero es de representación, o sea, de representación de conocimiento, por decir algo, ¿sí? Que conocimiento aprendido. Entonces vamos a tener 4 clases sobre esto. Ahí está el tema de embeddings, encoders, and, decoders, autoencoders y el mecanismo de atención, que es como probablemente el concepto más importante en Machine Learning que se ha desarrollado en los últimos 10 años. Y ya casi va a cumplir 10 en realidad. Después tenemos un bloque grande de modelos secuenciales, aunque ya no me gusta tanto ese nombre, tal vez lo cambio después, pero es un poco mirar de prácticamente todo lo que no es fully connected networks y redes convolucionales. ¿Sí? Todo lo que donde buscamos cómo manejar secuencias a través de datos. Y al final, modelos generativos. Aquí como hay una gran confusión porque todo el mundo habla de IA generativa, donde técnicamente hablando no es generativo, ¿sí? O sea, porque para... Eso es una batalla ya perdida, porque afuera lo que entienden por IA generativa es todo lo que produce contenido, ¿sí? Pero eso no es lo que es IA generativa o modelos generativos en el sentido técnico-académico. Y estos los vemos aquí al final, que son entonces los Generative Adversarial Networks, Variation Autoencoders y Diffusion Models. ¿Ok? Entonces yo estoy muy emocionado por el programa, está bien chévere. Entonces, estos van a ser como los 3 bloques. ¿Eso fue yo? ¿O? ¿No? Antes de poder empezar con esto, tenemos que tener como 2 clases que van otra vez un poco más a... No son una repetición de lo que ya vimos en el curso anterior, pero digámoslo, miramos desde otro punto de vista. Hasta ahora, al menos los que han visto conmigo estos temas, no han armado redes computacionales propios, digamos, customized, ¿sí? Sino únicamente usamos esa clase sequential de PyTorch para armar bloque por bloque una red, pero esto realmente es no lo que se usa para hacer cosas interesantes, porque uno necesita más flexibilidad. Entonces, hoy y la siguiente semana aprendemos un poco cómo es esto, o sea, para que podamos funcionar un poco en este ámbito, pero después ya empezamos con todos esos temas. Hoy y la siguiente semana es como muy hands-on, como muy programación, aquí para que veamos cómo funciona esto en términos de código. Después se vuelve bastante técnico a nivel matemático, ¿listo? También vamos a hacer cosas y aplicarlo un poco en la clase, pues tengo que mirar cómo nos va con el tiempo. Pero todos estos temas aquí son altamente no triviales al nivel concepcional, ¿sí? Entonces, estos son clases otra vez mucho más de, bueno, comprendamos estas ideas de estos modelos, ¿de acuerdo? Tal vez en un momento llegamos también a de usar un poco LLMs aquí en esta parte, pues tenemos que mirar un poco cómo nos va con el tiempo, pero esa sería la agenda. No sé si tienen preguntas, sugerencias, recomendaciones.
Bibliografía.
No, en realidad no. Bueno, hay bibliografía para algunos temas, pero yo personalmente desconozco un solo libro que cubre todo eso. Entonces, casi nuestra bibliografía van a ser los artículos que, usa, que hay para presentar esos conceptos, ¿sí? Estos temas. Para algunos temas como redes recurrentes y LSTMs, que ya son viejos y como tienen más material acumulado, para estos sí hay como, estos están en el libro que yo también usé en el Machine Learning 2. Entonces, hay un capítulo donde se explican estos y de hecho reuso las diapositivas, pero son pocos. O sea, en general no voy a recurrir aquí a un libro, por decirlo. Entonces, pero yo puedo compartir para todos, pero literatura sí puedo compartir para todos los temas. Entonces, puedo poner como referencias donde uno tiene como PDFs donde se puede investigar el tema. ¿Otras preguntas, sugerencias? ¿No?
Vamos a manejarnos con quizzes y con talleres, profe.
Sí, sí, vamos a manejarnos con quizzes y talleres. Entonces, la idea es que cada clase vamos a empezar con un quiz para los que están presencialmente. ¿Sí? Pero van a ser quizzes más cortos, o sea, vamos a hacer solo 5 preguntas. ¿Sí? Múltiples opciones. Para los que están virtuales, no hay la opción de quiz, ahí hacemos examen oral, pues en otro espacio. Igual, todos tienen la opción de un examen oral. ¿Sí? Pero los que vienen aquí también tienen la opción de tomar simplemente el quiz. Y sí, vamos a usar Gradescope otra vez para las entregas. Entonces tenemos como tenemos una plataforma donde se puede como subir código y ejecutar el código y les califica según el funcionamiento de sus entregas. ¿Ok? ¿Listo? ¿Todo bien ahí en línea también? ¿Nos escuchan bien?
Sí, por ahora sí.
Sí, profe, muy claro, todo claro.
Los tipos de los quizzes serán entonces más cortos, ¿no? Preguntas,
5 preguntas.
pero el tiempo de resolución.
Ah, no, vamos a hacer algo de 7 a 8 minutos, 8 minutos, digamos. 5 minutos, una por cada pregunta, más 3 minutos de colchón.
De meditación.
Sí. Sí, como las clases también son más cortas ahora, no quiero hacer como quizzes tan largos, no podemos perder tanto tiempo en quizzes. Bueno, aquí cuántos saben programar con objetos. ¿Quiénes no saben programar con objetos? Todos.
No saben.
Que no saben.
Yo hace rato no programo.
Profe, yo lo de programación de orientada a objetos es lo que pues se hizo en la universidad en el pregrado en ingeniería de sistemas. Trabajamos clases, objetos, polimorfismo, o sea, no sé si eso entra dentro de lo que se requiere en la clase.
Igual vamos a repasarlo, entonces tranquilo. Solo quería saber. Entonces, bueno, y voy a solicitar también, ya solicité con Miguel otro salón porque, de hecho, para lo que yo quiero hacer ahora, ya necesitaría mi tablero para mostrar cosas y no lo tenemos. Entonces, no es bueno. Entonces, la clase ahorita a veces no tan optimizada, pero a partir de la siguiente ya vamos a tener como mejores recursos. Entonces, me toca rápidamente buscar algo en mis viejas diapositivas, o no las viejas, en las diapositivas que tengo
Se puede fallar siempre, ¿no?
Señor.
Quien se te ve, creo que está perfecto.
Sí. Sí, pero eso es.
Pero tendrías que abrirlo un miro.
Primero eso y tampoco los otros lo podrían ver, ¿no?
No, yo sé que está compartido. Es pantalla de.
No, pero estoy compartiendo pantalla con mi Cortez. Baila.
Pero puedes poner miro acá. O sea, puedes poner miro acá y rayar allá, tal vez sí.
Vamos. No me quiero complicar ahora de sobremanera. Okay, very good. But then let's switch to English. So we will first talk about the concept of classes in Python, okay, and why we use it. So let's think of this. Let's think of this model here. So here we have a linear model for classification, okay, and we can use it to classify instances like negatively that are below the line and positively that are above the line. Now, when we want to make a prediction, what do we need here? Well, we need three pieces of information. First, we need a description of the line, or like the slope of the line. We need the intercept, and we need the point for which we want to make a prediction, right? So if we have these three things, you describe the line with the slope and the intercept. Okay, that's two pieces of information, and I give you the coordinates like like the coordinate of a point. Then you can say, okay, is this point below the line or above the line, right? So we can encode a function like predict that has three arguments, like w, which is, or like a, which is the slope, b, which is the intercept, and x, which is the point where you want to make a prediction. Now, the point is that if you want to make a prediction, you don't, with this model here, you don't want to carry on the description of the line every time. I mean, the guy who wants to make the prediction, he doesn't want to have to know about the slope. He just, I have a point, give me the answer. Not I have a point and the model, give me the answer. Doesn't make sense somehow, right? So how can we in Python somehow encapsulate this knowledge of the line somewhere so that the user doesn't need to provide it? This is like my example to motivate in this context the usage of classes. Okay, so here I've already prepared this for you. The idea now is really only to go a bit through how does object-oriented programming work in Python. So here we have a class that can I make this a bit bigger? Would be okay. Okay. Let's collapse this for a moment. So the function that I effectively want to have is this predict function. The predict function will tell me is something above the line or below the line. Okay. Well, in my case, actually, this example is not for classification, but for regression. So it's more like I give you the point, like the description of the house. Tell me what's the price of the house. Predict what's the price of the house. Okay, so it will be a regression problem. And actually, I only want to have this predict function, but I don't want to have the description of the line that tells me what's the price for which, like, house size. I don't want to carry on this outside of the class. So I want somehow this object to memorize. And this is the important concept of or the difference between using only functions or using classes. I could, in theory, only use functions, and everybody here knows how to use functions. But the problem is then I would need to do something like this. So if I know I have a linear model, then I would need to write something like def predict And what I need is a description of the linear model, which is slope and intercept and the x. And then here I could say, okay, if this here is my model, then I will make a prediction based on A, B, and X, okay? But I don't want that the person who uses this really needs to know A and B. That's the problem, right? The guy who wants to make the prediction, he only should know the X. Here is my point. Here is my house. Give me a prediction for the price. So how can I avoid that I need to have these two parameters here as a user? Okay, so where do these come from? Well, earlier I take data into train model. Okay, so maybe I've somehow a function fit where I put data x and y, and this trains this linear model. So here I would like train a linear model and return A and B. So this function here could so the money is gone. Money is gone. So yeah, we just wired 50 million pesos to the account of Manuel Figueredo.
One to continue.
Sorry. Okay. So what happens in the fit? In the fit, we take the data and learn a model. But what does it mean to learn a model? Then I determine the best slope and the intercept of a line, right? So that would be, I mean, this is not a regression problem, but it would be to find this guy here, right? So I describe it through two parameters, A and B, but where do I put these parameters A and B? In a function, I cannot put anything anywhere. In a function, I just can return something. Functions don't have a memory. Okay.
To transform into a global variable or something?
Yeah, exactly. So what you could do would be, if this here is your function, then you could say, okay, so let's suppose that this function would do something reasonable. Then you could say, okay, I have my data. Now do a fit on this data and return these two variables to me. And I make these variables A and B that describe the line, I make them global. Ugly. Now, I trained this model. You want to use it. So I have to send you in WhatsApp the description of A and B or what. So we don't want this because every time I want to make a prediction, I would have to use this. So I want somehow that there is a single thing that remembers these values of A and B and will reuse it every time that we want to make a prediction. Okay, and this is exactly then what this guy above does. So let's forget about this. Or I put it down here. So what does the linear model do? So first I define a class. What is a class? A class is really just a collection of functions and a common memory of variables. So it's two things. I have variables and functions. And the important thing is that these variables are inside of this thing. So when I said I want a thing that remembers these variables A and B, then the class will provide me exactly this functionality. Yeah. Okay. Well, everybody knows this already except one, I think. So, but so if you get it, we're good. Okay. So where do I say which variables here exist? So where do I put here into this class structure the A and the B? Okay. So the A and the B goes here, basically above here. And my first part now is to explain what this here does. So this here is a special function. Okay. So in Python, everything that is with like 2 underscores is a special, something special. It's also called like magics. Okay. So the idea is when I create a copy of this model, this will be empty in the beginning. Like I haven't done anything with it. I just created it. And it is like this thing where I can memorize stuff, but there is nothing there yet. But I will already say I have these 3 variables, weights, bias, and it's fitted. Now, what is this funny notation up here? This self. self is basically a variable that refers to the thing itself. Okay, so when you want to talk about this object, this is why it's called object oriented programming. If you want to talk about this object, you need a name for this. Okay, and this name is this variable self. So this is basically saying here the object talks about itself. So what this function here does is, it is called when you create a new model, and what this function here does is, okay, you create a new version of me. I'm still empty. Now the first thing that I do is I set a variable in my scope, which is called weights, to the value none. And the same with bias, and the same with is fitted. So I declare 3 variables that they exist. And I put the value none, so they don't have a value yet. Yeah, clear? One? Yeah. Okay, so here we say that this exists, but we don't assign any values yet. So when is this guy here called? When does this happen? This happens when, I really want to erase this now because otherwise it gets too ugly. So let's call this, sorry. So that would be called here. Okay, so if I execute this cell now, here I call not a function, but the class. Okay, so I use the name of the class as if it was a function. Okay, and what this here does is it creates a new object. And in this moment where I run this line here, this function above here, this in, this is then executed. Okay, this is called the constructor of the class. Okay, so after this, for example, I can ask what is object.weights, because this is then now a property. Sorry, this is now a property of this object. Here we don't see anything because of, but if I print it, then I see, aha, okay, so I've created a new object of this type, linear model, and it has a property weights, and it currently is none because that is what was assigned here. If instead I put blah blah and I run it, then this is what is going to be stored here. Yeah. What happens if I ask for another variable that has not been defined, like prediction, for example? Then I will get an exception because it said this object doesn't have this thing, what you're asking for. Okay. Okay, so this is like the first idea, that I can like encapsulate different functions and variables into these things, and these things we call objects. Okay, and the point is I can now create different copies of this. Like I can create a first linear model and a second, and they will not be the same. So if I fit the first one, then it will have its own weights and biases. And the second will also have its own weights and biases and is fitted. And this is important because if I have global variables, well, then this is becoming a complete mess. But here I have the variables nicely in a small scope. Okay. So,
Profe, disculpe, una pregunta. O sea, lo que va a hacer es crear un objeto para instanciar cada variable de la clase.
correcto. O sea,
Ok.
la clase es como, la analogía es eso. La clase es como, o sea, yo puedo tener una función que la defino una sola vez, pero la puedo llamar muchas veces. ¿Sí? Y así es con la clase. La defino una sola vez, pero cuando la llamo a la clase es como crear una copia de ese objeto. Y cada uno tiene sus propios variables. Entonces, mira. So let's put it like this. I can define also a new variable here, like 15. So I put into the first object, I put a variable that is called A. And it has the value 15 after I assign this here. Okay? But that does not mean that the second object will also have this. So if I ask in the second object, what is the value of variable A? Well, actually, I will even get an exception. Or let's not use A, but let's use the bias. Maybe a better example. So here I see, okay. So in the first linear model, I have a 15 in the bias, and in the second, I have still a value of none. Okay, so every object has its own copy of these variables, and this is super important. No? And that makes it super clean. This is why this is a super clean approach. And I don't have global variables. Now, the idea would now be to say, okay, and so here I can use these, or I can access the variables with this dot notation, right? Okay, so I have a name for the object, and then the name dot, the variable name, I can, well, receive the variable or write the variable, right? But I can do the same also for the functions, yeah? For the functions inside here. Now, sometimes you will hear the word method instead of function. This is a convention. So a function that is not global, but that is defined here in the scope of a class, this is usually not called a function, but a method. But in the end, it's, look, so here, it's called a method. So, but it's really the same thing. It's only like function, or like a method is a function inside a class, okay? And you could now like call it like with a fit, and then you put the X and Y, and everybody here has done this before, okay? But this is now we understand a bit better how this works. The important thing is now, if you look at the definition here of the function, you also see this funny variable self, yeah? And this self is not used down here. So here we just put the X and the Y. So Python internally always will assume that the first argument of a method is like the reference to the object. And why is it important to have this? Because inside of this function, of this method, sorry, I can use, I want to access these variables up here, okay? Maybe I can quickly do a simpler example where we do a new class. Let's like make a class where we so here I will say that we have a value of 0. And now I can create a new object of this class. And what we do now is let's write a function that will this is like a counter, this value, okay? I want to increase this. So I want a function or a method that will increase the counter. So here I define that my objects of class A will have a variable A, and I can ask what's the value of this variable A, and it's 0 in the beginning, okay? But now I want to increase this value, not from the outside, but on the inside. How can I make that this guy here increases the value of the variable A? Well, I could say A equals A plus 1, but the problem is that this A, he doesn't know where that is. He thinks that this A is only inside of this function. So that Python understands that this A is this variable of the object, that this is like in the shared memory, I need to use this this reference here, okay? So if I do this, then he will understand, okay, this A here is the same as this here. But for this, I need the self, and this is why I use it as a first argument always. So when you see the self, it just means it's the variable to talk about the object itself and to have access to the variables in the object. So if I now do here, hang on. So if I now do the increase, so I call this, I will not specify this first argument. This is implicit. I use it in the definition, but not when I use the function. Basically, this here, this is what goes into the self, this object, this here, this reference, okay? And when I now ask for the new value, then I see, okay, the value is now 1. Okay, so he's internally updated this stateful variable. So the thing about programming is always like, for those who already know it, this is all of this is super boring. And for those who are not familiar with it, it's even still getting too fast. Yeah. So it's, I understand that this is a bit tricky for those who have not seen it before, but it's mainly so that you have a first idea of what's the organization of all this and how to understand like the code that we will see. Okay. Now,
Profe, o sea que ahí estaríamos modificando, o sea, lo que veo es que en el primero declaró el object, lo declaró ese objeto de la clase A, pero al imprimirlo llamó fue a la variable, exacto, que está en el init, que en este momento la tiene inicializada en 0. Y ese mismo valor de 0 lo tiene asignado, como lo tiene con self, lo tiene asignado a la variable A, que en el momento que se puede ejecutar la variable de incremento, hay que llamar entonces al método de incremento, para que entonces sí pueda hacer el incremento en la variable A. O sea que si yo vuelvo a imprimir, un ejemplo, si vuelvo a imprimir el object, o sea, que está declarado de la clase A, va a imprimir en 1 automáticamente, sin tener que llamar al método incremento.
no. O sea, él aumenta únicamente cuando tú llamas esa función.
Ah, ok,
¿Sí?
yo lo incremento
O sea,
solamente cuando llamo esa
si no
función.
hago esto, mira, si no hago esto, entonces
Ah, perfecto. Ok.
pero tú también podrías, esa es la forma limpia para hacerlo. Tú también podrías ser más invasivo y hacer este cambio desde afuera. ¿Ok? Pero eso no es buena práctica. No es buena práctica.
Ok, sí, señor.
Okay. Now, this actually leads me to something that is maybe new to some of you, even who already know how this works. So in Python, you can do this access here, but it's actually deprecated. You shouldn't do it. Okay, you should not change objects from the outside. Now, in Java, you can protect variables. In Python, you cannot, but there is a convention. So there is a convention that says, if there are variables that I don't want to be accessed from the outside, I put an underscore in the beginning. This is not a formal protection. It's just like a kind of, I'm saying I don't want this to be changed from the outside. I can still do it, okay? I can still do this. But here, like this is suggesting something illegal. Yeah. Okay. When I see this code, oh, you're doing something that you shouldn't do. So if you access a variable that has an underscore in the beginning, that's not good practice. Okay.
So it's just implicit.
Yeah. It's a convention. So somebody said, let's like document whether a variable is protected or not, and let's use this. It's so you don't have a keyword like in Java where you say private or public.
In the moment you see that blank bar, you already know that you don't have to modify it.
You should not. So there should be another way. It's something that, and why shouldn't you do it? Because maybe they change it in the future, and maybe this variable is not going to be there anymore. So you do an update of your code, and your code doesn't run anymore because you access this variable and it's not there in the new version of the code. Now, but in this situation, I want to give at least read access. So what do you do in this situation? And this is a really interesting concept they have in Python. We could say, I want to do this here. I want that people can access the value of A, like this is like a getter, okay? Like in Java, you did this, okay? So now, in theory, you could do this, but we will say that's bad practice. Let's do this instead, okay? And this would work and would give me the value of A because I have a function defined that returns me the value, okay? But the cool thing that they have in Python is that you can, these getters you would do through properties. So here you use what is called a, how is this called? An annotation, okay? So you say this here is not really a function, okay? This is what we call a property. And we don't call it get A, but just A. Now, if we do this, then you can ask for object.a, while a is in theory a function, so it should be like this. Okay, it should be like this. Okay, it should be like this because a is a function. Yeah, but since we and it would be like this if we wouldn't have this property here. Sorry, so it's a bit delayed. So maybe it's better if I. Okay. I will look here also to see how synchronized we are. So if we hadn't the property up there, we would call the a like this. Okay. Oh my goodness. Okay, through a function. But this is not very convenient. So we would like to have something like this, just access the A, and we can do it using here this property declaration, okay? And this, oops. And this will now allow us to access A as if it was a variable, but it's actually not a variable. It's like a function that is working as if it was a variable, read only. The point is now with this, I cannot say anymore object.a plus equals 1 because now I get an exception. Okay. So that is probably new for some of you, but it's important because it's used a lot in these frameworks. Right? But I think up to here. So there is more to know or to be known. So I think maybe just one more thing. Let's say that what happens if we don't want to initialize with 0? Actually, this here is bad practice. Okay, there shouldn't be any constants in the constructor. So we should have something like this. So we should be able to configure the value of a initially when we create the object, and then here we use this value. Okay, so we can, but this here has a standard value, so we can still execute this code as before, but we also have the possibility to configure our own. I want to give a bit better experience to the people here in the room, so I will connect this because otherwise it's really super annoying with the.
When raise his hand.
Yeah, Juan, go ahead, please.
Thank you. Wondering why is that we cannot or we shouldn't be setting up variables on the constructor, Professor.
Sorry, I didn't understand the question.
Sí, me preguntaba por qué no podemos setear los variables en el constructor.
Porque, o sea, tú lo puedes hacer, pero eso significa que tú defines una variable que siempre va a iniciar con el mismo valor y no das la posibilidad de configurarlo. Es mejor dar la posibilidad al usuario de configurarlo.
Ah, vale, súper, gracias.
Ok.
O sea, profe, la idea del constructor es que inicialicemos unas variables por defecto y luego puedan ser modificadas a través del método,
Sí.
pero pues instanciado por el objeto.
Sí. Exactly. So, look, we can still use it as before because this here has a default value. If I take this away, that would be maybe bad because then I get an exception when I don't specify this value. But since I put a 0 here, it's basically the same effect as before. But now I can say a initial equals 15, and then I can start from another starting point. Okay, now I gave the possibility to the user to configure this initial value. Yeah. And I can, and by the way, so this is maybe also important here. So I can configure it in a different way every time. So I can create a new version of the same object, and the first starts at 15, but the second starts at 6. Okay. And that would not be possible if I would just have the value up here. Good. Now, one more thing I want to say about this is inheritance. So maybe let me now erase this here. So we can have a second class, but I say the second class is like a specialization of the first class. Okay, then I can say this here when I define the class. So up here, I say class and then the name of the class and nothing else. But here I say class B, and in parentheses, I say, and this somehow is a specialization of A. Okay. Now I want to say, I want maybe to have that all the objects of B, of type B, all of them start at value 10. Then if this is so, then I don't need this parameter here. I could still say like, what is A initial? But since all of the objects of type B should start at 10, I won't have it as a parameter, okay? And now, since B is a special case, I can access all the functions and properties of A as well. So every object of type B is also an object of type A. Let me show this. So I can now instantiate an object of type B like this, okay? And I can ask, okay, what's your property A? The property A has never been defined here inside B, okay? So without this, I would get an error. But since I have that B is a subclass of A, and I define it like this, then he will know, okay, this guy has everything that A has as well. Like everything that is up here, we also have it. Yeah, and maybe some additional stuff. Yeah. So for example, here, I could also put some new function, decrease, okay, which is not available in the first class. And here I could now say, I will reduce the value of A by 1, okay? So I can here say, initially I have a value of 10, and I can now decrease this like this. And then let's see what value I have. So the surprise now. Okay. Huh? Anybody understands why this happens?
Because we use the others curve in A.
And so A is a property. So I must do this actually. Yeah. So, okay, so I start at 10, then I decrease and I have a value of 9, okay? So B has everything that A has, but it has even more. I couldn't do the same with A now, with the A capital, because even if I put this value to 10, because what would happen? Well, A, this class doesn't have the method decrease, so I would get an exception here. Yeah. So this concept of inheritance is important because we will now define our own neural network blocks. And our neural network blocks will be classes. And they will inherit from a class that already exists in PyTorch. So we write our own class B, and they have already written the class A. And we inherit everything that they have written, and we can do something on top. Okay? This is why this is important for us. Okay, good. So this is the super crash course in 20 minutes, 25 minutes on object-oriented programming. Typically, you take like 4 hours for this. But okay, we had to do it a bit faster. And I hope everybody learned something at least here, even if it was just about this like property stuff and conventions of the underscore. So to repeat here, this super, this is a magic keyword that gives me like, so I'm as an object, I'm self, but who's my parent? Like who's the parent? I can't let him in because I don't have the Teams application here anymore. So somebody must let him in, please.
So,
So super gives me basically the parent class. So this super gives me the class A. Okay, and then if I have here my constructor, inside my constructor of B, I want to call the constructor of A. to make sure that I have an initial value. So always, I can always use this super to access the class from which I inherit. Okay. So good that we're recording this for everybody who's not very familiar, because I know that obviously this is all going super fast if you have never seen it before. Okay, but this is like then the overview for object-oriented programming. Let's use this now. Let's forget about classes A and B, and let's go back to.
Sorry, I have one question.
Yes, Richie.
What happens in concurrent scenarios?
Oh, no, let's not go into this. This is actually for Python, I cannot even tell you because I think concurrency is handled pretty badly in Python if you compare it to Java. In Java, it's really nice. But in concurrency, what can happen is like the object only exists once, at least if you're in a thread context. Okay, so if you're in a thread context, then you have a shared memory across the threads, and the object only exists once. And one thread can change a variable and another also, and you don't know when it happens. You can try to protect them in Java, but I think in Python it's not possible even. So, well, like, you know, with parallelism, it really depends a lot on how you do it. So if you one standard in Python is that you use processes instead of threads. So if you do this, then you have actually copies of the object. What that means is that if you change something in your reference of the object, it's only changed in one process, but not in the other. And this is super nasty. Actually, I hate it in Python because somehow it's always different than what you expect. But parallelism is really a topic for itself. So I don't want to confuse the others too much. But yeah, in principle, if you're in a thread context, you override values in the same object. If you're in a process context, you make local changes, but they are not changed elsewhere. And sometimes you want this, and you don't get it, and it's really annoying. Then you need to configure shared memory across processes and so on. It's a pain in the neck. Let's use this now. So we have this original class for the linear model. Okay, so now we understand this better. Okay, so we have a constructor to define weights, biases, and and information whether we have a trained model. And now I'm safe. Okay, so in the fit, we will call like linear model.fit with the data. And here will internally here, I don't want to explain this logic too much, but it's basically learning a linear model of the data using an algebraic approach. It's like, or an analytical approach. You can fit the Moore-Penrose pseudo-inverse to get the best model. And okay, but like the important thing here is we do something, we learn from the data, and in the end we have two values, the B and the A, so to say. So here we have the intercept, and here we have the other weights. Okay, and these are stored inside my object. So here what this is doing here, these two lines are basically memorizing, because at the end of the fit, the control flow is gone. What I memorize, what happened inside of fit, this is gone. So if I want to memorize something, I need to use self.something. So I say self.bias to memorize the value I computed here, because this theta, this is going to be forgotten once that fit is over. Okay. So if I want to memorize something, I need to use this. So here we memorize what we have learned, so that then in the prediction, we're doing what? In the prediction, we want to make predictions for some x, and we will just say, okay, take this x, multiply it with a weight vector, and where is the weight vector? It's stored here inside of the object. Yeah. So here we use the memory, and we add the bias. Here we also use the memory. Okay, so this is a very concrete example of how we use classes and objects to learn linear regression models. Let's use it.
let's use it for two data sets. So in scikit-learn, there are some regression data sets. So here, for example, we fetch not Boston housing, but California housing data set. Well, it's also a data set to predict prices, I guess. Actually, I haven't checked, but it's to predict numbers. Okay, so I get the data X and Y here. Yeah, I assume everybody's familiar with this, right? So, and then we create a new object of this class, linear model. This is now a model specifically for this data set, because with the class, I can build whatever linear model I want for whatever context. But now I want a linear model for this data. So I create a new object. This is stored in a variable. Then I call fit. And I call it with these specific data. And now my model here will be specialized for these data, because I memorized here. I do this logic and I memorize the weights and the biases. So this is like the description of the linear hyperplane to describe how these specific data here are best described. And then I can make predictions on, well, here I use the training data. Typically would do a train validation split and so on, but here it's only to explain how we can use it in this concrete case. So everybody has used this here before, like this logic in scikit-learn, I guess. But now we understand a bit better the object-oriented logic behind this. Okay, and now I can use another data set, diabetes, and I do exactly the same. I create a new model, I fit it, and I make predictions, but I have it in two different objects, so I have two different models. Imagine how that would be if we wouldn't have objects, and you would store like the bias and the weights in global variables and make predictions. That would be, I mean, would be completely impossible. So it's a very elegant concept, right? Object-oriented programming. So questions up to here. Yeah.
Just to be sure, in the case of fit, we are creating a variable that comprises the, I think that it would be the betas of this linear model. And that's just a function that is inside the class of the linear model. And I'm using that inside the function of predict to create the prediction, meaning that inside the linear model, I only really have the betas and the variance.
Mm-hmm.
Is that the case?
Yes.
Okay. Yeah.
So here in the linear model, you see that you have basically you have two shared variables that are important. You want to use this here and this. I mean, where does this come from? It doesn't fall from the sky, right? So somewhere you must store this, because in this function it doesn't occur before. So where does it come from? It comes from here. Here we do memorize this. And in the init, we just declare that these variables exist. That is not even necessary. It would even work if you don't do this. Yeah, so you can even don't do this. And because in the fit, you write this, he will make the assignment as you want. Okay, so we can run this here and it will still work. Okay, that's a bit different like in Java. In Java, you would have to declare this here. You don't have, but this is like more like good practice, so that you here you can see which variables exist. So what variables is this object talking about? It's more like kind of documentation almost. Yeah. So if you want to understand what are the variables that are treated in the scope of an object, you can look into the constructor, and then you see, okay, they are talking about weights and biases here, and is fitted. Okay, very good. Somehow, actually, this should also be like protected like this. Okay, but okay, it's a convention, and I'm also not always doing it. It's good practice, though. Okay, very good. So now, how do we use this? For there was another question, I guess.
I have one. Yeah, I can receive in the constructor a function.
Yes.
That variable, like
yes,
dependency.
yes, you can. Let's do it. Let's do it. So, actually, it's a very important use case. let's say, let's call it fun, okay? And so I'm again in the class B, right? So and we memorize this function this way. It's like we treat it as if it was a variable. Actually, you will not even notice that it's not a variable, okay? So if we do this, now fun is a mandatory object. So here we can do, I will declare a quick function that takes one argument, and we say the value is this, okay? That's my function, okay? And I can put this function here as an argument. So far, so good. This runs, no problem so far. I don't use it yet. Important observation, this function is not part of B, right? It's defined at the same level of B, so it's not inside of B. This is just some function that is elsewhere. So I can currently not do something like object.f. That doesn't exist, okay? But I can do this. I can ask for the value. Now, but what I can do is, I can do object.fun of 10, because this is now a property that has been defined up here, okay? And internally, I can also use it here. So I can first, for example, if I want to use decrease, I want first the value to be decreased, and then I want that this function fun is being invoked, okay? So I could use, I could do this here. So if I now do the decrease, let me here do the decrease. Then I say, okay, the value before is 10, then I do the decrease, but part of the decrease is to call also the function that I delivered before. And in this function, I could also do other, I could do operations, right? So I could say the squared value is, sorry. The squared value is x squared. So then I would get this.
I can make like the conversion coefficient function, right?
Yeah. And this is actually very important. Was there another question? Okay, very good. So now let's see how we use this for neural networks. Okay, so what you need here with PyTorch is just to do this. So it's not like in scikit-learn where you have to import like 150 packages or so. So it's just like you do import torch. And I mean, you can import submodules to have shorter code, but in general, it's fine with this. Okay. Now there is the core class that we need in PyTorch is this one here, torch.nn for neural network.module. What this is basically, it's a black box. It's a building block for a neural network or for a deep functional network. Okay, so if you remember the deep learning course, we were talking. Let me quickly go to the. Oh, where do I have these guys now? Slides here. So at the end, I think it was the last class we were talking about building blocks. Where is this? Oh, I think it's not here. Why is it not here? Okay, sorry, I don't have it now. But I mean, we saw that. Heck, why is it not here? I'm a bit annoyed now. Okay, but we know that the neural network consists of different building blocks. Yeah, so we have seen that we have the residual blocks and so on in the convolutional network. So this is the torch base class for building our own blocks. And it's actually quite simple. We only need two methods. So we only need a constructor that will tell it what is the input size and what is the output size. Okay, and actually we don't even always need it. But so we need a constructor and then we need a forward. The forward is like use the function. So somehow I can also think of a building block in a neural network just as a function, because it just like, for example, it squares or it computes a dot product between weights and the input signal, or it computes a sign or something. Okay, so actually it's only a function. But why do we have here then a class for this? Because the building block can consist of sub-building blocks, and we want to memorize these sub-building blocks. So what you do basically here is that you memorize the sub-building blocks you want to use in your building block. Okay. So if you have a block that uses 5 layers, for example, like a linear layer, then a convolutional layer, and 2 linear layers again, or something like this, then you put all these layers inside of this init here, so that you have them, that you have your block well described. And the forward is saying, okay, I have a concrete input signal for your block. Now give me the output signal. And here we will use all of these blocks that we define up here. Okay. So let's do a concrete example. So here I have a simple custom block. Okay, so I inherit here from this PyTorch module, and I say my input shape is input output size. And now what I want to do here is I want a a standard linear layer, but in the end I want to add some constant values. It's a bit stupid use case. It's just to show how this is being done. So what I do here in the init is that I memorize my linear block. So this here is, sorry, this is like a bit annoying with this tooltip here all the time. So this is maybe an advantage of Colab. It doesn't show you this tooltip all the time, which is not so great for presentation. So here, this class is like saying this is the standard linear layer. Take an input signal, multiply it with a weight matrix, and add a bias term. Okay, so this is what a linear regression would do, for example. Okay, we have to say what's the input and output size. So it transforms a vector of size input size to a vector of times the output size. Okay. And we memorize this. It's initialized with some random weights. We don't know. It's not said here. So you will put some random weights initially. Okay. And here we put some constant value. Okay. So here currently it's a 0. Okay. So this is memorized, and then in the forward we say, okay, I get a new signal. Sorry, I put my mouse away. So I get a signal X, and now I need to compute what is the output of my block for this X. And you can do whatever you want. Only you need to use the torch operators, because remember, compute graph computation. So what he needs is we can do whatever we want, but when we do the forward pass, he has to be able to see the gradient or compute the gradients. Okay, and this is safe whenever we use only torch operations. This was content of the deep learning class. Or if we want to use something completely new, then we can do this, but we have to define the how the gradients are for our operation. Okay, but typically you don't need it. Okay, so here we say, okay, we have an input X. The first thing that we do is that we apply the linear layer to it. So we get some new version of X, and typically you always write it like this. So update the X with the new value after the application of the linear layer. And after this, we add the custom bias we have up there. And after this, we put it into a rectified linear unit, and then we output this. So here you have basically this internal structure of your block. What's the computation that takes place in your block? No magic. It's just like we encapsulate this logic now into a class. Yeah. So here I create some random input. So here I create now an instance for this block. Okay. So what is this 10 and the 5? Yeah, input size and output size. So input must be a vector of size 10. Output will be a vector of size 5. Okay. Now I create not one vector of size 10, but 3 vectors of size 10. Okay. So here I have actually a matrix. I can say what's the shape of this guy, and the shape is 310. That means I have like a matrix 3 by 10. It's like I have 3 vectors of size 10. Yeah, one. Very floating or?
Don't worry about it.
Okay, but this here, this 10 and 5, it's clear what it is. Okay, so input size and output size of my block, configurable. I can do whatever shape I want. Yeah. And now I create some concrete instances X I can put into this. So here I create 3 instances for X. Each of them has 10 entries, and it looks like this. Well, it's some random numbers, okay? Okay, and then let me again take this out. So here we have created the block. Here we create the input for the block. Right? Typically, we don't create it. Obviously, it comes from the data, okay? And then we apply the block. Now you would say, wait, here I should, I mean, what does this mean? This is like the block is an object. The block is an object. And here I call the object. Which function would we actually call here? If I want to apply the block to this data, which function should I apply, should I call? Here I should write dot something, dot what? Dot forward, okay? And I can do this, okay? But we are inheriting here from this module. So in PyTorch, they already have said, you know, I give you a shortcut. You don't have to write dot forward. You can just write it like this, and it will do the same thing, okay? This is just a shortcut. This is because in Python, there is a special function that is called a callable. So you can treat the object as if it were a function. Typically, you can do this. So in my case above, you cannot do it. But here, this is allowed. But it's just a shortcut, okay? So this here is the same. I mean, I can also write it like this. So we can do it 2 times. Block.forward. Sorry, but here, let's not put the shape, but the concrete value. So you see, it's doing exactly the same thing. I get twice the same output, okay? It's just a shortcut. So, but I wanted to use the shape. And as you can see, the shape is not 3 by 10 anymore, but 3 by 5. And this is because my linear layer changes the representation from 10 variables to 5 variables. Yeah, this change in the shape is provoked by this linear layer up here. But I mean, this is just an example. You could also inflate it again. I mean, we could, for example, if we would just want to, we can do 2 linear layers here. Linear 1 and 2, okay? And here we say something like we do an intermediate size of 50. So the first layer changes from input size, whatever that was, to 50. The second changes from 50 to output size. And actually, that's bad practice because the 50 should be a parameter here. Okay, but I will, okay, let's do it just to give you an example. So mid size would be like 50, and here we should use this. Okay. Okay, so here the idea would be to first apply this linear layer. Apply a reloop, but then we can do just the same thing again, but now with the second one. And again, apply a reloop. Okay, so this would now be actually a block with 2 linear layers and a reloop unit between the 2. And we can run it and get an error. And why do we get an error here? Good question. I'm not sure.
I have a small question.
Yeah.
Inside of the linear, do we have a bias inside of the self-linear line?
Yes.
I guess so.
Yeah. And so it's like we have two biases. So the one that is learned and then the one that we add, but.
Hay alguien en el dispositivo front door.
What?
Disculpas, estaba sin mute.
Okay. I get it. The problem is here because this shape is different. So yeah. Okay. Okay, yeah, I get it. This here is because this must be mid size, not output size. Yeah, okay. So now it works, and yeah, and we again have the shape of 3 times 3 by 5, but in the middle we went from 10 to 50 and then to 5 again. Okay, so this thing with the shapes will be super important later on in the course, and large part of the documentation even is describing what are the shapes of the blocks. But what you can see and what is really important here is these 2 components for a custom block in a PyTorch network, because we will do basically only designing these things, okay? Or others have designed it already and we want to use it somehow. But the point is we cannot go back to the first course where we just said, I want a network with these 5 components in a row. No, we will not define networks anymore like this. We will even define the neural network like this. Because if I can define a single block, like having several layers, well, I can also define my whole network in this way. In the end, a neural network is only a huge block of many subblocks. Because these blocks I use here could also have subblocks again. Okay, and this is exactly what will happen. So we will now use this idea also to define our own neural network block, a neural network, the whole network. So we will not use this sequential anymore. But we will mount it like this. So this will be the way how we define a neural network. So let's look quickly at the clock.
One raising hand again.
One.
Yes, thank you. Wondering, because you call the object directly on that line where you are referring to block directly, yes. And you are passing the test input matrix, and somehow the class knows that you're calling the forward method. Wondering how's that happening, and what if we have other methods that are also getting an input like a matrix?
Okay, so the concept is Python callable. Okay, so I don't want to discuss this now in depth, but what happens is that there is this special function that is called call this here, okay? And this is like a forward pointer. So this is the function that is, or the method that is being used or being called if you use the object itself as a function. Yeah?
Got it, yes.
And what they do is that inside of this, they call forward. So this is the very short answer. But in general, so this concept is called callables, and this exists in many programming languages. So here we use it, to use blocks in our neural network. Okay, very good. I think we're a bit out of, well, we don't have time to do an exercise. I wanted to do an exercise here so that you could create your own block, but this is recorded and you will also have a worksheet. So everything's good. You can practice this at home. Yeah. So I would like to go to the train loop. Oh my goodness. Okay, something went wrong here. Let's import Torch first. Okay, so we should quickly recover how okay. We should quickly recover, for those who haven't been in my other class, how you train a network in PyTorch. Okay, so because there is no such thing like a fit. It's not like in scikit-learn. You create a model, you say fit, and you get something. This doesn't exist. Okay. So what you need is so for this, but it would be it is really important that you look at the class from the previous course. So I will upload the video. It's really important that you look at this because probably it's a bit difficult to understand right now. But what you need are two things. You need your model, which doesn't have a fit, but it has some. But you can use it. You can. So this model is the thing that has a forward method, or you just have data and call the model with this data and you get an output, okay? But it doesn't have a fit. And what you have is a train loader that like provides you with a chunk of data, like sequentially, okay? So with these two guys, you can then effectively improve your model because the model is basically, it's an object that can make predictions, but it also can change because inside of these models, you have weights and these weights will change in time, okay, when we train it. But how do we train it? So what you need is you need to define your objective function, which is typically a loss. Here it's cross entropy loss. This is the standard loss you have for classification. And you need an optimizer that will adjust the model up here. Okay, so here we use Adam, and we tell Adam that the parameters that he should optimize are the parameters defined in the model. Oh my goodness. If you have never seen this is going insanely fast. But yeah, so those who saw the other course with me have already practiced that a lot. So we tell the optimizer Adam that, look, the parameters or the variables you need to optimize, like basically the weights and the bias terms in my network are here. So in PyTorch, you can query the model for like a collection of all the parameters that are there. This is a very innocently looking call, but this returns you basically a list of millions or even billions of variables, okay? And tells Adam, here, you have to optimize these millions of variables. And here we define the learning rate, which is like the step size for the gradient-based method. And then we tell the model train. Now, don't be confused. This is not a fit. This is just that we tell the model, I'm now going to do something, and I need you to grab the gradients. So when I make predictions with you, remember the gradients in the forward pass. So this is, we're telling him you need to create the compute graph. Okay. Then we go through the over different epochs. Within each epoch, we run now over this train loader. Remember that I said you need two things: the model and the train loader. This is providing you the data. Now look, this is used down here. So we use this as if it was an iterable. So we're going in a loop here over the train loader, and in every iteration, the train loader provides us with a batch of data, right? The batch, the data. So it's not a single instance, it's a batch, and the batch size is configured in the train loader. And within each batch, we do a couple of things. The important thing is this here. We do a forward pass. So here we're doing this dot forward on the model with the data of the batch. This gives us some predictions. So here it's saying outputs. The outputs are our predictions. And now we compare the predictions with the ground truth and compute the loss. And the loss is what we want to use to update the weights. So three things are happening here mainly, or four things. This above here, we get back to this in a second, but then the three things are do a forward pass. This is going to happen here, and compute the loss. So forward pass and loss computation, this is happening here. Then do the back propagation, propagate all the gradients through the compute graph. This is going to happen here in this line, okay? Loss dot backward. This dot backward is computing the gradients, yeah? And in the third step, we tell the optimizer, Adam, okay, we have the gradients, now update all the weights in the network. This is what we saw all of this in the first course, right? Who remembers what this is and why we need it? Nobody?
Restarts the gradients to zero, because if we do not do that, it's going to rewrite over itself and it's going to make a mess.
It's not going to rewrite them, but add them up. So they will be added all the time. And I mean, if it would replace them, that would be great. Or what? I mean, so, but it precisely does not rewrite them, but will always add them. So we don't want to, in the new epoch or in the new batch, we don't want to add the new gradients to the old ones. So we reset them to 0 so that we have fresh gradients. Okay. So these 4 steps are essential in the this thing here, this loop, this nested loop. Epochs, and inside the epochs, the batches. This is called the train loop in PyTorch. And it always has these 4 steps. Set the gradients to 0, do a forward pass with current batch, compute the loss, back propagate the loss through the compute graph. This is this here, and then tell the optimizer to adjust all the weights in the model. So after this step here, our model is changed. It's weird because the variable model doesn't even appear in this line. Yeah, but still, this step here changes the model. Why? Because the optimizer changes the variables inside the model. How does the optimizer know the variables in the model? Well, we told it in the beginning here. Okay, so the step changes the model, and even though we don't have the line here, so this is a bit like, if you're not familiar with the logic, this can be a bit weird because you say, how is the model changed here if we don't even talk about the model here? But the optimizer knows the variables of the model because we told it in the beginning. Yeah, and this goes on forever. Yeah, we can go forever until we, but here we define a number of epochs before. Typically, you don't do this. Typically, you would use something like validation folds to see whether you have converged already, for example, okay? But in general, this is what happens. So we have to do our own fit. This is the fit loop, and we have to do it manually. Here I have some additional stuff to compute the loss and report it, okay? But this is mainly what's happening in the train loops. This is just like for repetition. Now what? What we can now do is, where do we put our model? Well, here. So here in this model, what we will do is that we, so first we define our class, like here. We define a child or a subclass of the PyTorch.nn.Module class. And here we define all our neural network, everything we want to do. Any computations we want to do, we define them here. If we want to have convolutional layers, we load them here and we use them here. So this is how we now replace this sequential block. So if you remember the previous course, we had always like this sequential and you put a list of layers. And we don't use a list of layers anymore. We say, here are the layers we need. There's no order in this. So, I mean, I could also here write it like this. Really, the order here doesn't matter. It's just saying what does exist in my network. I'm not saying in which order anything is happening. Where is the order coming into play? In the forward, because in the forward, I say now, in which way do I pass my data through my block? Or through my network, if my network is the block. Okay, so there's really no difference between block or neural network. It's the same thing. Only like, yeah, intuitively one thinks that a network is bigger than a block. Block is a bit like more atomic, but the blocks can also be quite complex. Okay. And we can first define our own block to do something, and then later we define another class for our network that will use our own block. And yeah, lots of the work in this course will be about this, about properly using existing blocks. But it will not be like, yeah, here use an attention block, like in the sequential structure, like attention block, and something else, but we will have to do something like this, configure the flow ourselves, okay? So this is how things are gonna work. This needs some practice. So there will be a sheet. I think there will not be so complicated, of course, like the sheets in the machine learning courses, because we have 15 sessions or 14 instead of 5. So it will be rather short sheets, but important to work on them. Okay. So I guess that would be like the summary for today. That was a very, like the classes will be very different from here on. It will be more conceptual, not so much programming, but of course it's important that we see this once so that you can do this at home. Okay. Questions? Yeah.
Are you going to publish this codes in a GitHub or repository?
I can share these notebooks with you. They are in a repository that I cannot share because there is too much other stuff going on in the repository, but I can share this, like, for example, in Teams.
Teams share.
Yeah, I share it in, I will create a Teams folder with like code material, and then we can write.
Thank you.
Other questions? Yeah, one.
For the following classes, are we going to have any form of exercises or sheets to work during the class?
Probably not, because we won't have the time. Because for me to explain the concepts will already take me probably the whole class, or 60 minutes at least. I will, when I prepare the class, I have to see whether we can do some coding inside of the class, but yeah, probably that's going to be left for the exercise sheets.
But it means that essentially we are going to use a class that is really similar to this one for the following classes. So this tool.
No. So we're not like doing something now that we reuse later. This is really only to understand the concept and practice a bit with this. It's not like we're going to reuse this in the next class. But it's a good exercise to understand a bit what's going on, and okay, because what we will use next time is this concept. So what we will have is that. So okay, now we want to use a recurrent neural network, and to use a recurrent neural network, what you or to do something with recurrent blocks, you need to say here, I want here a recurrent block and here as well, and then you use it down here. So if we don't understand how this works, then we cannot use these more sophisticated building blocks, because there is not, it's not like in scikit-learn anymore. In scikit-learn, you have basically the full classifier. You just instantiate it, you say fit and predict, and that's it. But PyTorch doesn't work like this. In PyTorch, you have a library of building blocks, and you must know how to use the building. This is how we use the building blocks. Yeah. Okay. Other questions? I get the feeling that English is working out quite nicely. Isn't it?
That's suspicious. It's bad.
Suspicious or surprising, or no, not at all. No, it's fine. But it was just like Miguel said, oh no, you can't do it in English, but apparently we're good.
Yeah.
Apparently, yeah. Okay, very nice. Bueno, entonces muchas gracias a todos. Yo creo que va a ser una chimbita. Este curso intenten llegar presencial porque la dinámica es mejor así, ¿no? Pero bueno, siempre vamos a hacer las grabaciones y todo, pero sí mejor. Y bueno, entonces éxito con la primera hoja. Ya saben cómo es, pero lo que les dije va a ser como más, un poco más suave en ese sentido. Entonces nos vemos hoy en 8, pero en otro salón.